Welcome everybody, and good to see you all again here live in the audience, and welcome to all of you out there here at the GCCM in Lisbon. We're talking about the submarines and actually the latest technology innovations and developments. And for this, we have the senior executives lined up for you, and I'll give them a quick minute to introduce themselves. So Jeff, welcome.
Thank you, Eric. Yep. Welcome, everyone. My name is Jeff Bennett. I am Director of Solutions and Technology for Infinera, and we're a manufacturer of high-performance SLTE, submarine line terminating equipment, including transponders, and my presentation is actually going to be about how to extract the maximum capacity from any given cable type.
Okay, thank you so much and welcome, and thank you, Infinera, for sponsoring this session. So next to me is Frederick. Frederick, hi, warm welcome to you as well.
Thank you. And I'm from Eastern Light, company building a new fiber optic network in Northern Europe between all major data centers and mainly with sea cables.
Okay, thank you. Good having you. And last but not least, Takahiro, welcome.
Hi, good afternoon. Takahiro Sumimoto. I'm SVP Marine Cable at NT Limited, headquartered in UK. And I'm joining from California. I'm also CEO of Pacific Crossing, the owner and the operator of the Trans-Pacific Cable PC1. And we have major cable routes in the Pacific, PC1, and intra-Asia, ASC and APG, and some other cables. Thank you.
Okay, thank you so much, and a warm welcome to you. And hopefully next time you can join us live here. On the stage. So thank you so much. All right, Jeff, I think you have something very interesting to share with us, with everybody around here, and broadcast it live on the World Wide Web. So please take it away, and good luck.
Thank you very much. So as we know, there's a whole variety of subsea cables out there. According to telegeography, there are 428 active cables. There are a lot of cables in planning. That number is already out of date. It's a lot more than that. We have over 1,200 landing points around the world. Many of you are involved in those landing points. And the interesting thing, of course, is that we have multiple generations of cables. Now, I'm going to be using numbers from transatlantic cables, so we have a like-for-like comparison across the decades, as it were. But of course, we started with compensated cables that were designed for regular 2.5 gig and 10 gig transmission. These days, we could achieve up to 10 terabits per second per fiber pair on a cable like that, a classic cable like Apollo. Then we had uncompensated cables. The Rolls-Royce of transatlantic cables is Maria, and we've achieved performance up to 28 terabits per second on an individual fiber pair. That has service level margins. It's not just a hero number. And that gives us 224 terabits per second for the cable as a whole. There's 8 fiber pairs on Maria. Of course, the latest generation of cables are SDM cables. First of those is Dunant. We've achieved 26 terabits per second on a fiber pair and 312 terabits on the cable itself. So that's the goal of SDM, increase the cable capacity by compromising slightly on the fiber pair capacity. And then a new cable announced by Meta. I mean, we've made some projections about the capacity on that one of around about 21 terabits per second per fiber pair. But that's a cable that's capable of half a petabit per second transatlantic capacity. So some key questions. For modern transponders that can be configured in infinitely programmable ways, what's the best baud rate and what's the best kind of modulation to use in order to extract the maximum capacity from any of those cable types? Because it takes years to plan a new cable. It'd be wonderful to have new cables on every route, but by the time you've laid that new cable, somebody's come up with a better design anyway, because it's taken so long to deploy it. So it really makes sense to extract the maximum capacity from existing cable types as well as the new ones. So let me give you some background on reach at particular data rates. I'm going to use the 800 gigabit per second data rate as an example, because it's the highest data rate that the current generation of transponders support. So I'll be looking at the reach, the baud rate, and the modulation. In order to achieve 800 gigabits of actual payload, the lowest baud rate you can transmit is 84 gigabaud, because at that baud rate, you are using the full 64 QAM constellation. Now, just as a note, as you move up to these very high order constellations, you reduce reach quite dramatically. So I'll use that as the baseline reach, the ×1 reach. If we increase the baud rate to 96 gigabaud, we suddenly find we can increase the reach by a factor of 4. So we're not talking a few percentage points here. This is a massive increase in reach. Why is that? Because we don't need to use the whole 64 QAM constellation. We can actually gain some advantage using probabilistic constellation shaping, or PCS. So now we're carrying the equivalent of 10.5 bits per symbol. Turning it up a little bit more, 100 gigabaud, that's the highest baud rate available from a commercial transponder today. And we get another 30% or so of reach. That's a 5.2 times factor on the original reach, but that's carrying 10 bits per symbol. So we're trading off spectral efficiency for higher wavelength data rates. Why is that important? Because the higher the wavelength data rate you can support, the better your economics. The fewer transponders you're buying to support a given service load, you're using less electrical power, using less rack space. And i6 Turbo is actually our particular product operating at 100 gigabaud. Now, this leads to the conventional wisdom that we should always use the maximum baud rate that the transponder supports, and PCS will always deliver the optimum modulation performance. Now, that seems to be true in most terrestrial links, but is it true in subsea? Well, in fact, when we test on all sorts of cables, now Maria being a classic example of an uncompensated cable, but these kinds of fibers actually have a Q versus frequency dependence. So Q, you can think of as the signal quality. The higher the signal quality, then the further above your commissioning limit you're operating. But it has this dependence. The lower frequency parts of the spectrum are actually better than the higher frequency parts of the spectrum. Now, of course, we've got to operate above the forward error correction threshold, because if we drop below that, customers will start seeing bit errors. That's very bad. And because we don't like to have our lives being too exciting, we actually have a service commissioning limit. We have a threshold well above the FEC threshold that we'd like to actually commission links at. And that is down to the individual fiber pair operator to decide that. Now, of course, we have to support real data. We can't just come up with sort of 425 gigabit data rates or 363 gigabit data rates, because they are not real clients. We have to support integral clients like 100 gigabit Ethernet or 400 gigabit Ethernet. So for a given client data rate, if you have a transponder that's just operating at its maximum baud rate, you have to configure it for optimum performance at the high frequency end of the spectrum. And what that means is that over at the low frequency end, which is a much better part of the spectrum, you are leaving margin in the fiber. Now, that margin could be revenue generating services. So what we found is that by still operating at high baud rates, but just dialing it back or dialing it up a little bit, we can adjust the spectral width of the signal and squeeze more capacity out of the cable. We call that margin monetization, because you're turning that excess margin into revenue generating services. Now, what about PCS, probabilistic constellation shaping? Now, I'm not going to tell you what that is. I don't have time in my brief introduction, but we have a white paper on that. And there's no doubt PCS offers amazing advantages versus fixed modulations like 64 QAM. How can we make PCS work better, though? And are there times when we shouldn't use PCS in a particular deployment? Well, one way to make PCS better is to give it more notice. Now, this is a technique called using long code words. So let me try and explain what that is. What we're doing with PCS is taking a random bit sequence where the probability of there being a 1 or a 0 is the same. It's 50-50. But now you pass it through something called the distribution matcher, because what the distribution matcher is trying to do is to match as many inner symbols in the constellation as possible, because the outer symbols of a constellation like 64 QAM bad symbols. They're high energy symbols that have a higher nonlinear penalty. Now, the distribution matcher is a real opportunity for vendors to add some value. So this is our secret sauce. And so what it's going to do is match symbols to a three-dimensional Gaussian distribution. And you can see the probability of using inner symbols is much higher than outer symbols. To help it do a better job, the distribution matcher can look further into the data stream. And that's actually called a longer code word. A code word length is the distance it looks into the oncoming data stream. We can also make PCS better by using a technique that is, it's a really interesting aspect of modern transponders, which is if you have a spectrum analyzer and you look at an individual wavelength, it's not just one contiguous band of energy. We synthesize digital subcarriers in our transmitter. And this is all one wavelength. These are all coming from one laser, but you can see 8 distinct subcarriers. This is a 96 gigabaud carrier, so it's a high baud rate carrier, but we modulate each subcarrier at 12 gigabaud. So it has a lot of the optical properties of a low baud rate signal, but you're getting all the advantages of a high baud rate signal. Even so, the edges of that carrier are exposed to more optical impairments on their journey along the fiber. Now, we're trying to go as far as possible. We're trying to carry this 800 gigabit signal as far as we can. So the analogy I think of is where you have one of these team building events where there's 8 of you and you have to carry 800 pounds of payload as far as you can in an hour. And you're a team. There's no point in 1 or 2 strong guys getting to the end before the rest of you. So one option, of course, is to distribute the load evenly. Well, there, the weakest members of the team will limit the overall distance that you travel. And those will be the outer subcarriers because they're the ones exposed to more optical penalties. So an alternative approach is to redistribute the load in your backpacks so that the inner subcarriers are carrying more of the load and the outer subcarriers are carrying less of the load. So now they're still exposed to the penalties, but they're not working as hard. So they're able to essentially go further. Now, the manifestations of that, this is dynamic bandwidth allocation, by the way. On a subsea cable, we typically have a fixed distance. Obviously, the cable is a given length, but we can support a higher data rate over that distance using DBA. In a terrestrial network where you have a whole set of different route lengths, then what you'll find is that you can go further at a given data rate. Very often in terrestrial networks, you don't optimize every wavelength or every link independently. Somebody makes a decision. We're going to go with as many 600 gig wavelengths or 800 gig wavelengths as we can. And you try to close as many links as you can at that data rate. Now, when we look at PCS, it's not always the best modulation option in some circumstances. Now, this is a graph of the bits per symbol. This is the spectral efficiency on the vertical axis and optical reach on the horizontal axis. And you can see this non-granular step function. Now, one of the problems with a situation like this is that traditional QAM modulations, the fixed modulations, they're not very granular. So at points where you drop off between 2 different modulations, for a very small increase in reach, you experience a big drop in the capacity of that wavelength. What PCS does is smooth those jumps out, and it allows you to recover the bits under that curve, which is really good. It's an excellent technique for that. But you'll notice when we get to about the equivalent of QPSK, PCS is losing efficiency. So what we found is that instead of using PCS, if we go back to traditional modulations, but we then take advantage of subcarriers so that on each subcarrier, we can be using a different fixed modulation in a hybrid approach. It allows us to do certain balancing of the signal, phase balancing, polarization balancing, and so on, in order to achieve better optical performance. And again, we can squeeze a little bit more capacity at fairly low spectral efficiencies. Now, these kinds of cables are long dispersion managed cables in the Pacific, classic examples of those kinds of cables. where it's very unlikely that you're going to get new cables anytime soon. So the ability to extract a bit more capacity is very important. We've seen between a 25 and 50% improvement in capacity on these kinds of challenging cables compared to a PCS-based approach. So in summary, we have multiple generations of cables. Cables are engineering miracles, right? They'll last for 25 years in astonishingly difficult environmental conditions. But newer cables are always going to be delivering better performance. It takes a lot of money and a lot of time to deploy those new cables. So the longer that you can upgrade the existing cables through transponder upgrades, the better your finances look. Now, conventional wisdom works well in terrestrial networks, and that conventional wisdom is always use the highest baud rate of the transponder and always use PCS. But in most subsea networks, you need to step away from conventional wisdom. You use the programmability that's built into these 5th generation transponders by varying the baud rate slightly on uncompensated cables. We can use advanced PCS features like long code words and DBA to achieve maximum performance on modern cables. And on challenging cables, older cables, we can use hybrid non-PCS modulations on those systems. And we end up with 15 to 25% more capacity on modern cables, uncompensated and SDM cables, and 25 to 50% more capacity on the older, more challenging cables. So hopefully I've stayed to time, and thank you very much for your attention, everyone.
Thank you. Thank you, Jeff. That was very interesting. And let us check if there's any question for you with regards to your presentation. All clear? All loud and clear? I have one question. In your last slide, you mentioned there is 15 to 25% more efficiency by using the transponders. But does it also count in money? So the end of day, end of length of a cable, does it do the economics work?
Well, the 15 to 25% increase is in real payloads being carried. So that's real services being carried. So I think it does translate to money. And obviously, the more capacity you can squeeze out of a cable, the better your economics. So that's really what we're trying to do. Yeah.
Okay, thank you. So, okay, guys. So the topic of today is, of course, the latest technological innovations and developments. And we are discussing this in the submarine landscape. So, Frederick, maybe if we can start with you, can you give us, let's say, an overview from your perspective with regards to the submarine landscape we see today?
Yeah, first of all, I think I strongly support the idea of multiple cables solving the same problem. So by upgrading, it's not only about giving more capacity, but also instead giving better redundancy. Let's say that you have a route between two certain points and you just had one cable and then you deploy a new one. My experience right now is that the customers, the end customers, the hyperscalers and traditional operators like mobile operators, they prefer to have multiple links. But then you are taking a risk. We, for example, added new capacity between Sweden and Finland, the first new sea cable for like 15 years. And now we know that our new cable carries much more information than all the other cables in together. And we know that the day when we will have a failure, we will be beaten up by the customers fixing that cable, even though they have lied to their customers that they know we have redundancy. So I think that in one way or another, cable lifetime will be much longer in the future. And especially if you combine it with the idea that permission to lay a cable, according to our experience, is much harder to get now than compared to like 20 or 15 or 10 years ago. So I think that the commercial lifetime of a cable needs to be much longer in the future. And we foresee that with our Festoon cables that they will live for like 50 or 60 years. And therefore you need from the very beginning to really learn how to upgrade the cables, both Festooned and amplified systems. And in general, we think that high fiber count is very important. And it's also not only because of the capacity, but that more customers like to possess their own optical link in the cable. Not, I mean, being able to use optical encryption and other things that are there for protecting your assets or information assets from tampering by enemy governments or things that are new. And so I think that technology will need to solve the need for better redundancy, higher fiber count, much longer lifetime on existing cables. That's like a short version of it.
Okay, thank you. Takahiro, what is your take on the, let's say, the submarine landscape? Well, what do you see?
Okay. The submarine cable design life is 25 years, and I am the owner and operator of the PC1 cable, which was built in 2000. And according to Jeff, it's a challenging cable, very challenging in terms of.
Can imagine, yeah.
Yeah, and we conduct this, we conduct a series of upgrade because we are certain that our cable life will go beyond 25 years. So I conducted 8, 9 upgrades in the past, and we are still upgrading because there's strong demand in the Trans-Pacific. So it justifies, the demand justifies the upgrade. And we increased, Jeff mentioned 25 to 50%. Yes, it is, or more in our case. So we need to continue to upgrade to meet demands. Otherwise, well, we will be soon sold out, but there's strong demand, so we'll be upgrading. And we certainly see the capacity shortage because everyone goes online. So we see the capacity shortage between the US and Singapore via Japan. And we certainly continue to upgrade, but we need additional cables. And we also witness the difficulties in laying the cable because of the challenging regulations, or you need to secure diversity. So it is getting more challenging. And also we need to deal with getting more difficult environmental regulations. You can't dig the beach, or you can't dig the roads on the land so many times. So we need a high band capacity, and we need to minimize the construction period. And so I mean you want to build a cable with a big bandwidth, not smaller bandwidth with so many cables. So that's what I see in the last couple of years. Thank you.
Okay, thank you, Takahiro. Jeff, you want to add anything to this on, let's say, the characteristics of the submarine cable landscape?
No, I think it's interesting, this idea of extending the cable life beyond this original 25-year limit, because what I'm hearing is with the advent of SDM and pump farming, it may well be that we could have a 30-year engineering life with those kinds of technologies. And of course, with an unrepeated cable, it's just a piece of glass. So as long as there's not too much damage to that cable during its lifetime, other than ropers, of course, sorry, which is a piece of glass, but different piece of glass. Other than damage, I think it's and by the way, the unrepeated cable market is a real sort of sleeping giant. I think there's a lot of opportunities for unrepeated cables.
Do we see those opportunities?
Oh yeah. Please.
Yeah, and I must add, we had with one of the hyperscalers, we've been having a discussion for like 8-9 years on using sea cables between traditional, between cities in the Nordics where you have traditional dig on land. But then if you take into consideration that on land, you have like a jointing box dig down every like second or third kilometer, and then your link is like 500 kilometers. Just that number of enclosures that needs to be waterproof, and then, you know, maintaining that fiber on an optical quality level that will be able to use the most modern equipment, that cost for maintenance will make it impossible compared to a C cable, where you actually you have a lot of fights in order to being able to deploy it. But then the deployment itself, it's ultra fast compared to digging on land. The carbon impact on deploying a C cable compared to doing it on land is nothing. And then finally, the number of like cuts are less at sea compared to on land. It's just, it works that way. So we have seen that the hyperscalers are much more interested in unrepeated sea cable links now compared to like just 2-3 years ago. We think that development will continue.
Okay, talking about sustainability, gentlemen, how do the latest technological innovation and solutions help to build sustainable networks? And maybe we can dive a bit more deep in of what the latest technology innovations are. Jeff, maybe if you want to start off.
So from the transponder side, there are two different ways you could answer that question. One would be for older cables where the focus historically has always been on the capacity per fiber pair. So there, you're really looking for the highest possible transponder performance in order to extract these very high data rates per wavelength. When you're doing this, it means lower carbon footprint because of less power consumption, less rack space. All of these benefits apply. So now let's take a look forward a few years to SDM cable evolution, where the emphasis changes from capacity per fiber pair to capacity per cable. And one of the consequences is there's almost a deliberate look at lower data rates per wavelength than we're achieving today. But we don't necessarily need to use the kind of transponders that we're building today. There could be pluggable transponders in the not too distant future that have the kind of performance you need for, maybe the next generation of SDM cables. And what that means is, okay, fair enough, you have more transponders, but instead of a transponder being the size of 2 shoe boxes, it's now a pluggable, QSFP DD or that kind of form factor. So that would be, I think, a major step forward in sustainable transponders.
Takahiro?
Yes, as Jeff mentioned, upgrade is the solution for the boosting demand. And in our case, NTT is now currently planning to build a new trans-Pacific cable, and we are planning to have 25 pairs in that cable. And I understand that 24 is in the trans-Pacific. And I would think that beyond 24 fiber pairs, we anticipate that multi-core fiber multi-fiber pair cable will be developed, but this will require a technological leap. So in conjunction with the multi-core fiber, a smaller optical amplifier needs to be developed to be incorporated in the repeater. And enhanced capacity and improved operability will be the key to the advanced transmission system. That's my view.
Okay, thank you. Frederick?
Yeah, on our Fastone side, we are actually now putting down more than 800 fibers in our next cable between Sweden and Finland. Yeah, but the idea is that the fiber is not really the cost. It's everything else. Even equipment is more costly than fiber if you use that many fibers. So we think that because we foresee this, that the lifetime will be much longer in the future. It's so that, and then you need more fibers. And I think with the carbon footprint, the interesting thing is also that there are a lot of other aspects on environmental things in Northern Europe, with mammals being in the sea, that yachts needs lower noise. And we foresee that the demands on sea cable vessels for repair, for example, will make it most likely that it will be driven on electricity with large batteries on board in sensitive areas. And I think it will gain the sea cable industry that there are talks about environment and carbon footprint, because I think that compared with other type of technical solutions, the environmental cost is much higher. So that therefore I think so I see rather possibilities than problems with it.
Hi, your voice is fading. So could you repeat the question?
Sorry, can you hear me now?
Yes, I can hear you, right?
I think there was my microphone, so apologies for that. So what role does an efficient supply chain and logistic management play to meet the demand? What's your take on that?
Okay, we are not the we're not manufacturers, so we have to we are dealing with the difficult supply chain issues because we need to plan a upgrade in a timely manner, and logistics. We also we have difficulty in receiving equipment. But the only thing that we can say is that plan well in advance, and we have to make decision quickly and ahead of others. We need to order the equipment, and agility matters. That's we're not directly manufacturing, so just we are conducting the upgrade or construction. So we just need to agile and be ahead of others. That's what I can say at this moment.
Yeah, on the point that this first the pandemic and then the war in Ukraine has I mean, we need to wait for everything now associated with the project. Everything from like steel plates to our ILA sites to the sea cable itself. So it's really, things that took 1 year now will take you 3.5 years. And we desperately hope that it will change. But the good thing is that the waiting time for permitting feels less terrible now when we need to wait for equipment and things like that. So by planning, as you said, I think that's at least is our solution. And we also feel that the customers actually understand that there will be more waiting time for things. And I don't know whether this is to stay or whether it's and we have also seen problems with getting deliveries of fiber itself, as especially when we do this very ultra high fiber count. Just the number of kilometers of fiber is very limited. And actually, in our case, I don't know if you can guess what the longest, like the most time-consuming thing. It's actually coloring the fibers. As you need to do that coloring, and it takes time, and the fiber arrives on small bobbins with 100 kilometers of fiber, and then you manually had to put it up in a equipment and then color it. And so it's and just imagine if you would color one fiber wrong or use the fiber, it will create a massive delay in the repair, maybe 15 or 20 years later, when those guys are already sitting here in Portugal on a nice beach or something like that, instead of being on that repair vessel.
Exactly, being on the beach. Well, we have a nice venue here in Cascais as well, right? You agree, right?
Yes.
Yeah, you see, they woke up again. So, Jeff, how can you support the guys? Well, because it's your fault by the end of the day. You know that, huh?
I guess.
Yeah.
Well, okay, let's take a different perspective on supply chain issues.
Yeah, please.
You can, there have been photographs of the ships outside the port of Los Angeles. And there are hundreds and hundreds of massive container ships. They're just sitting there. Normally they'd be there for a day or two. They've been there for like months. They're running their diesels to power their internal electrical systems. They've got to load on food for the crew. Crew aren't allowed to leave. The cargoes, how many of those cargoes are in some way perishable? Because they're now baking under the sun. They weren't supposed to be in that situation for that long. So in terms of the wastage, we can just see it sort of in photographic form with that situation. So what can we learn? We can learn to have more sophisticated and tolerant supply chains, because I think we've got to learn something from this, right? When the whole world goes through the kind of situation we've all been through for the last few years, the one thing you can try to do is learn from various mistakes. And the whole just-in-time process, you could point your finger at it and say, oh, that's to blame, but we've all benefited from it for the past 40 years or so.
Oh, yes.
And interestingly, the only company that really understood it, Toyota, they weren't caught out because they recognized the weaknesses in their supply chain, and they bought extra components to sort of shore up those.
So
those
to
weaknesses.
increase stock again.
Exactly.
So old school.
Old school.
Old school, to have it in stock, but that costs money.
Yeah,
right?
but it costs even more money if you can't deliver.
Afterwards, we know the answer, right?
Yeah, exactly. Yeah.
Because we were a just-in-time economy, globalization, everything, right?
Right.
So where do you think, I mean, that is looking at the problem. So solving the problem, you say we need to learn from it. So how do you support us, Infinera? How do you support, let's say, your clients in this next to education? Because you're right. I mean, Los Angeles is one, but you want to see the footprint from Shanghai.
Oh yeah, it's replicated all around the world.
No, but it's a tenfold
yes,
of that.
yeah.
It's a tenfold of that, of the ships and whatever, which is laying there. So the white Teslas you all ordered, they will be orange when they will be delivered, right? So, no, but so how can you, next to education, how can you support your customers?
Well, businesses go through these strategic trends of, you remember when Nortel made so much of their own product in-house, everything from electronic chips, optical chips, and so on. And then of course there was the trend of, oh no, outsource that, sell it off, because those businesses will do what they do best. To Asia. Exactly, yeah. At Infinera, we've actually taken an approach of vertical integration, having as much of the critical optical components, particularly within our own control. Photonic integration is something that we've pioneered for over 20 years, I suppose. On the electronic side, of course, you see this highlights an issue. On the electronic side, of course, a coherent transponder is a combination of optical components and electronic components. And you have to have the latest electronics. It's got to be the 7nm A6 from TSMC, which is where everybody else buys them from. Is it a Dutch company, ASMR, is it? That
ASML.
Yes. ASML, that's
ASML,
it.
yeah.
That build the UV.
They build actually they're number one in the world. They're building actually the machines to build the chips.
You're right.
So, and if you want to see their order portfolio of today, they're full for the coming 18 years.
Wow.
They're scaling up 50,000 people in the coming 2 years just to get to that demand.
Yep.
So crazy. And then you're right, because it's not only Los Angeles, it's not only Shanghai, it's even in the Netherlands. That's why there is it. The demand is so high. But good to see that you try at least as much as possible to. Yeah, no, absolutely. All right. Takahiro, if I may come to you, please. Can you explain the audience about the importance of secured and smart cable networks management and here we go, the maintenance deployment?
All right.
What can you share with us?
Okay. So as I mentioned that everyone went online during pandemic, and instead of traveling abroad, people discuss online as we do now, or I'm doing now. So 99% of the global traffic goes through submarine cables. And cables carry important data for individuals as well as corporation and government. And since they are exchanging critical data, we need a secure network. And cable operators are tasked with operating a stable network. And if something goes wrong, obviously we need to fix the issues as soon as possible. We need to provide and maintain a secure cable network. And I can say that our cable landing stations are subject to security audits by the US government. So we can confidently say that we are maintaining the required level of security. And inside our cable landing stations, we are reducing the equipment footprint by upgrading the equipment. We'll be replacing the equipment with less exhaust heat, with more bandwidth. So we are able to reduce the power consumption on HVAC. So network is upgraded while ensuring energy and eventually cost efficiencies. The lower cost will be of benefit to both users and operators. And I can share one thing that our network monitoring system is now going to cloud. So that this will eventually allow technical staff members to monitor network from outside network operations center or cable landing stations. This will be powerful in terms of business continuity. If there's something happens, say earthquakes or natural disaster, but we can, our staff can monitor the network from outside of the technical, network operations center or the landing stations. So we can keep the network up and running. And as for environmental issues, MTT announced the new environment and policy that carbon neutrality will be achieved in 2040. So I expect that we will diversify the source of energy, combining with conventional power and renewable energy consumption. So that is the kind of quote unquote smart cable network management, which we are aiming at. Thank you.
Okay, so but putting the things in the cloud, is security not even becoming more a bigger topic for you then?
It's it's a quote unquote secure in terms of the in terms of what we're planning. It's not something that easily compromised one, of course not.
Okay, thank you. So Frederick, also for you, the importance of secured and smart cable networks management. What is your take on that one? And the maintenance deployment, of course.
Yeah, first of all, we are talking about fiber integrity, that we continuously measure a lot of data from our fiber cables from the very day of the first deployment, already before it's commissioned, as we would like to make sure that no one has put in some sort of optical small devices that potentially could tap or interfere the traffic. And we think that that the importance of the cables will grow over time, and we think that it's wise to install equipment that, in our cases with the Festoon cables, we are not having any active equipment on the seabed, but we foresee that we will anyway use the same type of equipment as in the definition of like smart cables with them in the really long haul cables, to be able to detect things that is happening around the cable and potential threats to the cable. And we also foresee that as we are carrying a lot of traffic for other operators and things like that, we think it is very important for us to keep our control systems really out of the internet or any cloud, as we are like the provider of services to the cloud providers. So we have decided to have our NOC based on our own fiber network, actually, where we have digged into a building and then having the NOC inside that building, so that we know that no one will
redundancy with two building entry points, or three or
and
four,
all
or
things like that, and adding a lot of security to ILA sites. Historically, the ILA sites in Northern Europe has just been small shelters with absolutely no security at all. But we are adding a lot of things like that, and we think that will continue to be so. But the good thing is that even if you do it for security reasons, you will earn more money as the uptime will be higher in the end of the day. And then one other thing that we are actually doing, we are planning some like 100 ILA sites in Northern Europe. We are adding toilets, kitchen, and all things like that. It used to be that all landing stations in the Nordic had nice and proper facilities, but then they were taken out for financial reasons. But then giving the fact that it's not that nice if you need to use a bathroom on a small island in the archipelago outside of Stockholm, and there is no bathroom. And we have been, our customers are so happy about us doing that type of things. And it's the use of Raman amplification that has made it more tricky to install equipment. And I think that Raman amplification will be even more used in the future than today.
Okay, Jeff, what is your take on the security side? Well, what do you see around you? What do you hear from your clients?
Well, I mean, security has been an issue for a long time. And I suppose a trivial answer would be, of course, we've got line rate encryption. We have the various security certifications for the equipment. But I think Fredrik's hit on an interesting point, because if you think about a coherent transponder now, it's almost a test set. There is so much telemetry that comes out of the transponder. Now, the hyperscalers are actually collecting that. I mean, because they've got like infinite amounts of storage, they're collecting it. This is exactly how you use big data. You collect it with no knowledge beforehand of what you're going to find in there, but then you send a deep learning neural network into it and working on it, and then like 2 months later it pops out, oh, did you realize that there are these correlations? And that's exactly what you can do with that kind of telemetry. But you can look for, you don't necessarily need to correlate events. You know that something's happened. You see the spike, you see the change in parameters, because we can track all sorts of things. Classic example, of course, now being earthquake detection. Now that's state of polarization change, and it does use amplified cables, because in order to localize the source of the earthquake, you're bouncing off consecutive amplifiers. That's how you sort of zone in on it. Tricky to do in an unrepeated cable, but it's happened on the unrepeated cable. You just don't know where it is along the cable. In terms of faults, though, coherent OTDR. I mean, there are various tools now that we can add to that mix to make the whole thing more secure.
Okay, good stuff. Let me see if there's any question from the audience. You're so quiet, guys. Is it because it's end of the day, or you want to have a beer? Margarita time. I just heard. I didn't want to comment on this one, because I commented on my previous session about somebody having I'm sick socks, So I didn't want to say, but you're surely wearing the right stuff. So okay, let's wrap it up a little bit. Takahiro, looking in your glass ball, I know it's very difficult, but scoping a bit the future, what will we see? What's out there? What can you tell us?
All right. Well, adopting green technology is a must for cable operators as well. And I think new cable landing stations will be more energy efficient, and fiber network will carry more capacity with more efficient use of energy. So equipment will have a smaller footprint with less energy consumption. So that way our submarine cable network will be more advanced with green technology. That's the immediate take or immediate thing that I can foresee. Thank you.
Okay, thank you. Fredrik?
Yeah,
help us, enlighten us. What's out there? What's going to happen? What's going to hit us?
Yeah, I think that we are like it's hitting us right now. And I think one of the major changes is really that not only capacity will be the important thing, but uptime, environmental aspects in all sorts, and new things. As I foresee that the next major cable cut that just happens out of an accident or whatever will make people aware of the importance of sea cables. And I think that the legislation associated with sea cable protection will be more developed in the future. And I also foresee that there will be much higher fiber count in all types of fiber optical sea cables. And just to make us all think a little bit about technical development, finally, one of the most common questions that we always get from our investors, banks and things like that is that, okay, you know, fiber. What about anything new that will be here in the future instead of fiber? Then I just need to remind them of the fact that Mr. Raman, the Indian guy that made all this thinking more than 100 years ago, he actually got the Nobel Prize in like 90 years ago, approximately. And now we are seeing the components and the systems based on that thinking that he made 100 years ago. I think that is fantastic. So if there will be something happening with the photons that we work with, we will for sure know it much. I mean, it's like 100 years. So nothing fast will happen. It's just some sort of evolution that is taking place. And I think that is the fun thing with fibers, and especially fiber optic sea cables, that there is a slow evolution.
Let me quickly throw you a curveball. Should governments get more and more, let's say, a stake in the cables? Because we discussed this and tipped on this one earlier in the sessions and also yesterday, because fiber, digitalization, digital transformation, blah, blah, blah. But it is now on, especially in Europe, number one, number two on the agenda. So do you think that if there would be, let's say, not only the recognition by the governments that fiber is key, submarine cables are key, I mean, dry, wet, well, whatever, it's all key because it's our bread and butter. Because before we have our first coffee, let me do this survey. Before you have your first coffee or tea in the morning, or milk or juice or water, whatever you have, how many of you check first their cell phones? Be honest now. Don't lie. I see still a couple of Pinocchios here. You see? So it's the majority. So it's our bread and butter. I mean, Omantel called it earlier that they called it the new oil, right? So throwing the curveball, do you think, I mean, there's investment enough. There are enough bankers and enough investors out there who would give you the money. But should governments also, in whatever thing, back it up or make it more important or help with permits or what have you? What would be your take on that one?
I would say that I think it's very important not having governmental ownership of cables.
Thank you.
One, yeah. But I think it's so many things that can be done, and the most important thing is competition. So that we often get questions, you know, what if we let you land this cable here? Can there be any other cables? Yes, there can be. I mean, each sea cable consumes so little resources on the seabed. And I think that one very important thing is that there should be some sort of ITU initiative or something like that, sorting out in the way of how to get rights of way on the seabed. That is one thing that could be done by governments. And it will never happen, I guess. But it should be nice, especially in Europe, we could do it, but it feels like every country has its own ideas. And one bad thing is really that wind farms and other bad things happening out there consumes a lot of land. And I don't see a problem having both wind farms and some sea cables going around. But it seems that the idea from the lawmakers now is that we block certain areas from wind farms, and then you're not allowed. You know, like so, but I think that private ownership is very, very important, but with good legislation and good help from the governments on understanding the importance of multiple sea cables.
Yeah, because knowing that sometimes you even hear or read about it, that some, ships which are booked for the coming 36 months. So whatever you want to lay down a new cable in 3 years from now, maybe you're the first one to, have a ship to do that. I think that at least they should support it. They should not interfere. I fully tend to agree with you,
that's the first
because
step.
let the market do this, because we're far good enough to do this and to handle this. Although that a bit of old school stock, having things in stock, is becoming interesting, and maybe manufacture things not everywhere in Asia, but also have it maybe a bit in Europe or in Africa, which is closer by, guys. Come on. And but a bit of more support, through ITU or whatever, that would help, because I heard about that the ship was laying on the ocean for 3 weeks doing nothing because of what we call afterwards a stupidity.
Yeah, and it's the same everywhere. And it's so funny that when we started the Eastern Light some 12 years ago, we went to the conference in Singapore, just to realize that it's functioning or dysfunctioning in the same way globally.
Yeah.
So it doesn't matter in which country you are, it's the same.
Yeah. All right. Okay. Jeff, closing statement. What is your takeaway?
So in terms of the government issue, all I'm going to do is agree with Frederick, because I'm British and I'm not particularly proud of our government at the moment. So I'm going to step away from the government thing. What I will do is perhaps mention the excitement of, so what comes after the fibers we're using now? We talked about multi-core fiber. That's solving the problem of smaller space, fitting more fiber into the cable. But the one I'm really interested to see how it pans out is hollow core fiber. Hollow core fiber, you're transmitting through either a vacuum or through air rather than through glass, so you've got lower latency. Potentially you have a much wider band of transmission, not just the C and L band, with low attenuation. And you again, potentially you have a lower nonlinear penalty. So you can crank up amplifier powers, improve your signal to noise ratio that way. So this is a way of getting lower latency, higher fiber capacity through these fibers. Now, they're all the good news bits. The bad news bits, can you make it? It's incredibly complex. It looks really delicate. Is it the kind of thing that can live on the bottom of the seabed under hundreds of atmospheres of pressure?
Let's try it.
Yeah. What happens when you splice it? And if it's got a vacuum in it, the vacuum's gone.
Oops.
Yeah, and it might now be full of seawater. Yeah. So I think there's so many questions to answer, but it's really exciting, the possibilities.
Please, Frederick.
Yeah, and just I read yesterday in New York Times that for the first time there had been 3 quant computers connected with the fibers in Amsterdam, I think it was. And quant encryption and quant computing will definitely change a lot of things. If you want to use quant encryption between 2 addresses, you need to have a physical layer to transmit your quant energy in. And that means that fiber radio cannot be used, for example, but you need fiber. And I think that will also be very, very interesting to see where it happens. And it's happening. It will be there within 10 or 15 or 20 years, but not longer.
When we are all old and
we are not that old.
No, you not. You're not, but I am. Thank you very much. Thank you very much. So a lot of things to look out for. I still think everything looks bright. The demand is there, and I would like to thank you, Takahiro, for being with us. And as promised, next time you'll be alive here. I would like to thank Frederick, of course, and Jeff, and also thank you, Infinera, for sponsoring this session, and you here for all your questions. But at least, guys, thank you for being and staying with us. I think the content was more than important for everybody to learn, maybe bits and pieces left and right. So thank you so much, and thank you out there for being globally with us. So from the Carry community and the GCCM in Lisbon here, we're going to close it. Thank you so much. Stay healthy. Bye-bye.
Thank you. Thank you.